Dear colleagues, my name is Ekaterina Mironova. I am PhD, head of the Laboratory of Molecular Neuroimmunoendocrinology, St. Petersburg Research Institute of Pulmonology, and senior researcher of Laboratory of Molecular Mechanism of Aging, St. Petersburg Institute of Bioregulation and Gerontology. Today I will tell you about vasoprotective properties of peptides in vivo. Cardiovascular disease is one of the most common pathology with a high mortality risk in elderly and senile people. The main causes of death are ischemic heart disease and atherosclerosis. According to statistics from the World Health Organization, myocardial infarction is the cause of death in more than 30% of cases. In Russia, cardiovascular disease accounts for approximately 55% of the cases of total mortality. To date, there is a trend toward a decrease in average age of cardiovascular disease manifestation. A feature of the course of cardiovascular disease in the elderly is a combination of various body systems pathology, which leads to the use of various pharmaceuticals. Existing medicine used in the treatment of cardiovascular disease in people of older age groups have limitations due to side effects. They can cause dysfunction of the gastrointestinal tract, increased synthesis of liver enzymes, clouding of lens, disorders in the hematopoietic system, mental disorders, and myopathy. In this regard, the search for new effective and safe treatments for cardiovascular disease is particularly relevant. The study of the functional activity of blood vessels under normal conditions and in pathology, as well as the possibility of regulation of these processes, with the peptides open up new prospects for development of vasoprotective drugs that are highly effective at treating cardiovascular disease and free of side effects. From the polypeptide complex went forth, which was isolated from the vessels of young animals, the tripeptide vasogen was synthesized. It was found that this tripeptide has a wide spectrum of action in various experimental models. Studies were conducted on the effectiveness of using Wentworth to stimulate the respiratory and cardiovascular system's function in a model of experimental hypothermia in rats. After applying Wentworth, the heart rate during the cooling process was statistically significantly higher than in the control group. After applying Wentworth, the respiratory rate during the cooling process began to decrease later than in the control group. The temperature limit for breathing cessation after the use of Wentworth decreased. The time to breathing cessation increased by 2 times compared to the control. Thus, Wentworth slows down the cool depression process of respiration and cardiac activity. The effect of Wentworth on the cerebral cortex microcirculation in spontaneously hypertensive rats of different ages, 6 and 12 months, was also studied. It had been shown that a single course of Wentworth administration to young animals increases the density of microvascular network in the pial membrane, the system of veins and arteries of the pia mater, but 1.2 times. In hypertensive rats at the age of 12 months after 2 courses of the Wentworth administration, the density of the microvascular network increased by 1.6 times. In addition, the hypertensive rats at the age of 12 months after 2 courses of Bentford administration, the level of perfusion blood flow intensity increased by 15 relative to the intact animals of the same age. Animals in this group were more easily tolerated to cerebral vasospasm, application of a vasoconstrictor to the surface of the brain. They maintained a high level of tissue oxygen saturation with unchanged perfusion rates. In all rats aged 20 to 24 months, the density of the PLM microvascular network increased significantly, approximately 2.5 times. The constrictor and expansion reaction of the PL arterioles increased when norepinephrine or acetylcholine was applied to the surface of the brain. At the same time, perfusion in the cerebral cortex tissue didn't increase, but the degree of blood saturation in this tissue area microvessels was. Intravenous vasogen administration resulted in a significant dose-dependent decrease in the blood pressure and blood flow in the abdominal aorta, carotid artery, and cardiac output in cats. Using the vasogen administration in animals, a pronounced increase in the calculated indicator of total peripheral vascular resistance and vascular resistance of the carotid artery and abdominal aorta regions was also noted. It can be assumed that the increase in the calculated indicator of vascular resistances in response to the vasogen administration could be a consequence of cardiac output and blood flow decreasing in these arteries. Vasogen had a normalizing effect on the capillary condition in a mild periodontitis model in rats. The vasogen increased the resistance and permeability and also improved the microvascular condition of the gingival and periodontal mucosa. Bentford and vasogen highly affects on the animal vascular system in various experimental models of vascular pathology. It was demonstrated the homeostatic, endothelial-protective, and vasoprotective effects of these peptides. This opens up new prospects for the medicines development that are highly effective at treating cardiovascular diseases and free of side effects. Thank you for your attention.